Hey, welcome back. This video is about the cast rule, and it's actually connected to the diagram drawn in a previous video. This diagram here that indicates where the opposites and the adjacents are positive or negative. Let's go back to this and look at what happens if I label these quadrants. I'm going to label the bottom right quadrant with the letter C. I'm going to label the top one with the letter A. The top right one. The top left, I'm going to label with an S, and the bottom left, I'm going to label with a T. Now, what happens inside the C quadrant? I'm just going to pick on one quadrant here. It's kind of vague what happens in the C quadrant. What I mean by that is what happens to trig functions evaluated at angles that are inside that quadrant. So let's pick on sine first. Sine of theta is going to be opposite over hypotenuse, which is the opposite inside the C quadrant is negative. Hypotenuse is always positive. So we're going to get a negative output. It doesn't matter what the angle is inside that quadrant. As long as it's inside that quadrant between 3 pi over 2 and 2 pi, then the sine of an angle in there is going to be negative. The cosine of an angle in there, so adjacent over hypotenuse, well, the adjacent's positive, in the positive x direction. Hypotenuse is positive, so we're going to get something positive. If we do a tan theta, tan is opposite over adjacent. The opposite's negative, the adjacent's positive, so we're going to get something negative. If we do a similar analysis for the other quadrants, what we'll find is that for angles in the A quadrant, all three of the trig functions are going to be positive. For angles in the S quadrant, in the top left, only the sine function will end up with a positive evaluation, and the cosine and the tan will both be negative, because the cosine and tan both involve the adjacent, whereas sine does not involve the adjacent. The sine involves only the opposite, and the opposite is positive in the top left. If we move to the T quadrant, where the adjacent and the opposite are both negative, because they're the negative x and the negative y, then the sine is going to be negative, because it's opposite over hypotenuse. Cosine is going to be negative, because it's adjacent over hypotenuse. And the tan is going to end up being positive, because it's going to be a negative quantity over another negative quantity, and the two negatives will cancel. This combination, or this outcome, can be summarized with another acronym, similar to SOHCAHTOA. The acronym is the CAST, or CAST rule. In the bottom right quadrant, the C quadrant, only the cosine function is positive. Top right, the A quadrant, all of the trig functions are positive. In the top left, only the sine function is positive. And in the bottom left, only the Only the tan function is positive. Okay. So that's where the cast rule comes from. It's a quick way to indicate what angle you're in. Or it's a quick way to determine whether the output of a trig evaluation at an angle in a certain quadrant is going to be positive or negative. For convenience sake, I've provided this diagram of different angles on the unit circle, different special angles. All the orange ones are special increments of pi over 6. All the green ones are special increments of pi over 4. And all the purple ones are special increments of pi over 3. When we evaluate a trigonometric function at an extended angle, so let's say we evaluate a trigonometric function at 7 pi over 4, the first thing we are going to need to do is to figure out what quadrant we're in. If we're in the C, the A, the S, or the T. Once we determine that, we can ignore the coefficient in front of pi. So let's say I want the cosine of 7 pi over 4. I figure out the quadrant. And that will give me either a plus or a minus of cos of pi over 4. So plus if in C or A, minus if in S or T. And that's for the specific to the cosine function. And this is perhaps the quickest way, most efficient way of evaluating trig functions at the special extended angles. Figure out the quadrant, then it's either going to be a plus or a minus of the cos of the angle without the coefficient in front of pi. Then use your special triangle for that. Now, a little warning here is that to use this trick for evaluating trig functions at special angles, the fraction must be fully reduced. So if you have something like, let's go, think of one. 8 pi over 6. Say you want the sine of that. Well, you can't say it's going to be plus or minus the sine of pi over 6 because this is not a reduced fraction. You need to reduce this fully. So factor 2 from the bottom, factor 2 from the top, and cancel the 2's. This is 4 pi over 3. Then the sine of that is going to be plus or minus the sine of pi over 3, depending on where 4 pi over 3 is. Is it in the first, in the C, the A, the S, or the T quadrant? So just watch for that inside this method. Make sure it's not a non-reduced fraction. So I want to work through some examples of how to evaluate the trig functions at extended angles, starting with special increments of pi over 3. So sine of pi over 3, that's just a special triangle. I'll draw the relevant special triangle. There's your pi over 3, the other one's pi over 6. Opposite the pi over 6 is, since it's the smallest angle, is the smallest side, which is a 1. Opposite the pi over 3 is a root 3. And then across from the 90 degrees is the hypotenuse, which Pythagorean theorem says is 2. Sine of pi over 3 is the opposite over the hypotenuse, which is root 3 over 2. Okay, that's all there is to do. Next one, sine of 5 pi over 3. So the trick is, first check, is it a reduced fraction? It is. So this is going to be plus or minus sine of pi over 3. We got to figure out the plus or the minus, based on the quadrant that we're in. We need to figure out the quadrant. Okay, so I'm going to figure out 5 times pi over 3. 5 times pi over 3 is 5 times 60 degrees. So here's my first increment of 60 degrees. And then here's my next one, 120, 180. So that was 1, 2, 3. We need 2 more. 240. We're down here at 300. So you may have done these types of diagrams with the little arrows, spiral diagrams. Everyone teaches this differently. This is the C quadrant. So sine is negative there. So we travel up to here. That tells us it's going to be a minus sign. So negative sine of pi over 3, which is negative root 3 over 2 from the special triangle. Okay, let's think about the next one, bottom left, cos of 5 pi over 6. Okay, it's reduced fraction. So the trick is this is going to be a plus or minus of cos of pi over 6. We need to figure out the quadrant. So I'll draw a picture. Pi over 6 is equal to 30 degrees. 5 pi over 6 is 5 times 30 degrees, 150 degrees. So you can either figure out where that is based on the 180 being to the left, 90 being up, or you can draw out 30-degree increments. I'm going to draw out 30-degree increments. So here's our first 30-degree increment. Here's our second one. Here's our third one, up to 90 degrees. Here's 4. Here's 5. So there's your 5 increments of 30 degrees. We're inside the S quadrant. And cosine is negative in the S quadrant. So that tells us this is going to be negative cos of pi over 6. We can use a special triangle. It's up above. Negative adjacent over hypotenuse. So it'll be negative the adjacent. So we're going to pi over 6. So it'll be root 3. And the hypotenuse is 2. So that'll be our answer. Okay, now the last one has a little bit of a twist to it. 2 over 3 is reduced, so it'll be plus or minus tan of pi over 3. So I'll leave a space there. Plus or minus opposite over adjacent. So I'll leave another space, and then the opposite going up to that reference triangle, pi over tan of pi over 3. The opposite is root 3. Adjacent is 1. So it'll be plus or minus root 3. I'm leaving spaces there to figure out what to put there, plus sign or minus sign. We had to figure out what quadrant we're in. So here's the twist. A negative angle, first positive angles, go counterclockwise. Negative angles are clockwise. So we have to go not up and to the left as we rotate our angle. We want to go down. So our first angle measurement, actually I should write this down, that pi over 3 is equal to 60 degrees. Negative 2 pi over 3 is equal to negative 2 times 60 degrees, which is 120 degrees clockwise. I'm going to draw the increments. So here's your first increment of 60 degrees, going clockwise. And then here's your second increment of 60 degrees. So we're in the T quadrant. So the T quadrant, the tan function is positive. So we're going to have a plus sign here, plus. So our answer is just root 3. And I'll continue in the next video.